Okay, this is the second video in the No Math Jail series, helping you not to go to math jail. So here we have a 2 times the quantity x plus 5 squared. People who are going to math jail have been doing this. And distributing the 2 inside the quantity like psh, even though there is clearly an exponent out here, and then all kind of bad things happen. It really doesn't matter. This right here, distributing a coefficient into an algebraic expression that is being raised to a power, will land you in math jail. Let's talk about why. Why? Because of PEMDAS. Our old friend PEMDAS is out to get us once again. Ladies and gentlemen, you must take care of those exponents before you can multiply. So, because I can't do what's in parentheses here, obviously first we want to do anything in parentheses, the first thing I'm going to do is multiply out x plus 5 squared. Now, we would be in math jail if we did this. That would be bad. If you watch video number 1, you would see why that is math jail. If you did not watch No Math Jail video number 1, go back and do that right now. So we are going to carry down the 2, and it's going to become x plus 5 times the quantity x plus 5. We're going to multiply that out, and it's going to be 2 times x squared plus 5x, and then another 5x and plus 25. So we would have 2 times x squared plus 10x plus 25, and the correct answer would be 2x squared plus 20x plus 50. Alright. Another way people have been going to math jail is when solving equations like x squared equals 4. The correct way to solve this is to either take the square root of both sides or to raise both sides to the 1/2 power, if you have learned rational exponents. Math jail is when you then take the square root of both sides and you are solving and you get x equals 2 only. This will put you in math jail. Why? Well, because when you square a positive or a negative number, you will always result in a positive number. The directions here are probably said solve. When you solve, you want to find all possible x values. All of them. Not some of them, all of them. So whenever you take the square root of both sides, you must remember that that number x could have been a positive 2 or a negative 2. Let's extend our example a little bit. Let's say we had x to the 4th power equals 16. All right. Now you can approach this 2 ways. You can take the 4th root, or you can raise it to the 1/4 power. I'll raise it to the 1/4 power, just for fun. You can take the 4th root if you want. This is an even power. Because it's an even power, I have to remember, what number multiplied 4 times gave me 16? Well, it could have been positive 2 or it could have been negative 2. On the flip side, if I have x cubed equals 27, I do not need a plus or minus, and here's why. Take the cube root of both sides. Then you're going to get x equals only 3. I don't want that there. Because we're multiplying a number out 3 times. If I do 3 times 3 times 3, I get 27. But if I do negative 3 times negative 3 times negative 3, I get negative 27. Even roots, even fractional exponents you must put a plus or minus in front of your answer. Alright, let's do one more. When you add together 2 radical expressions, one thing people do that lands them in math jail is they just add together the argument. They add together what's underneath the radical. And they say, okay, well, 12 plus 27 is the square root of, let's see, 939. Yay! No! Bad. You cannot add two numbers under a radical, and here is why. Our old friend PEMDAS once again. Parentheses, exponents, multiplication, division, addition, subtraction. You need to remember that that radical is like an exponent. If you've studied rational exponents, you know that this can be, that can be rewritten as 12 to the 1/2 plus 27 to the 1/2. And we must take care of any exponents before we add or subtract. Now, if you haven't studied rational exponents, just think about it like this. The square root of 12 is some decimal. The square root of 27 is some decimal. When you add them together, you are not going to get the same decimal. Let me show you what I mean. We know the square root of 4 is 2. We know the square root of 9 is 3. If I add together 4 and 9, I get 13. The square root of 13 is some decimal. It is not 5. If you want to add together two radical expressions, you need to almost treat them as if they need to be like terms. Right now, this is a root 12. I cannot add it to a root 27. What I can do is think about the root 12 as the square root of 4 times the square root of 3. And the square root of 27 is the square root of 9 times the square root of 3. You can multiply underneath a radical. Let me show you. If I've got the square root of 9, let me switch colors here. 8, stop it. If I've got the square root of 9 times the square root of 16. Let's just take a second here. We know that the square root of 9 is 3. We know that the square root of 16 is 4. And we know that 3 times 4 is 12. If we do 9 times 16, for those of you who need a little assistance, 9 times 6, and then 9 times 10, add them together, 90 plus 54 gives you the square root of 144. The square root of 144 is 12. You can multiply and you can divide under a radical. You cannot add or subtract under a radical. And it all goes back to treating a radical like an exponent and what you are allowed to do under an exponent. The correct way to do this problem is to take the square root of 4 and make it a 2. The square root of 3 stays the square root of 3. The square root of 9 is 3. Now, I have 2 square roots of 3 plus another 3 square roots of 3. And together, that makes 5 square roots of 3.